Hello, everyone. I'm going to talk about some updates on the past year on the open source multimedia community. So for those who don't know me, I've been working on VLC for far too long, and I've been active in FFmpeg, X264, David, and other multimedia projects. We're going to talk mostly about FFmpeg and David today, because a large majority of you in your product are using FFmpeg in a way or another. Right? FFmpeg now is one of the open source projects that is used everywhere. It's almost infrastructure. And last year, I explained what we were supposed to do for FFmpeg.5, 5.0, and 5.1, and changing of the release schedule of FFmpeg, which affects a lot of you, and also what we were going to do for David. Right? So I'm here 1 year later and show you exactly what we did. The good thing is we almost did exactly what I said we would do. So for once, I'm not going to be too late. FFmpeg 5.0 is a major, probably one of the largest FFmpeg release ever. Why? Is because we spent around 2 years deprecating and removing APIs, right? So just removing all the APIs took around 300 commits. So we removed the code that was deprecated in 2013. And well, FFmpeg 5.0 was supposed to be out in winter 2021, and it came 1 year after. But it's large in terms of number of contributors, 150 contributors just for this version. It's a major API and ABI break for everyone. We're sorry about that, but it's good because you're going to like what we did. So the third thing is that now you have a single API for audio and video, no different calls. Everything is decoupled between the input and the output, so no weird API calls like in the past. We did a lot of improvement in SW scale. Everyone said that SW scale was dead. Well, still people use it, so we started working again on it. And some new APIs like the bitstream filters. A lot of changes you don't see, especially we started disentangling AV format from AV codec, which is a lot of thread safety and issues. You'll see why it matters afterwards. There is now slide threading in SW scale. We have also features like IMF support, Dolby Vision, metadata support. It's not great yet, but it's still like a bit. We have hardware support for encoding ProRes and VP9 on macOS because you're the only one who have that. And there is something that probably none of you have seen, but now you can use placebo inside FFmpeg, which gives you a lot of filters, super resolution, tone mapping, reverse tone mapping, deinterlacing on the GPU. But there is a way to run that also on the CPU if you don't have a GPU. And of course, I'm not going to list all the filters and game codecs and weird features that we added because it's too long, but a ton of those, right? So, yeah, okay, there is a problem. You can't see correctly the slide. Yeah, so the old API, you were like in the same loop, calling either AV codec decode video 2 or audio 4 or 5 or 6, whatever the name was. And then in the same loop, then you were basically dequeuing your packet. Now, basically, you're sending all the packets asynchronously, and then you receive the frame. And an AV frame can be either audio or video, right? So it's simpler. You don't have to have separate paths between audio and video. Of course, some of you are going to complain because subtitles is still different. I will do something about that in the future, promise. But yeah, so you're going to move to 5.0. It's going to be painful, I'm sorry. But it's for your own good, especially since we're going to work a lot on maintaining better FFmpeg releases for you. So 6 months later, we did FFmpeg 5.1, which was in July and was not late. Of course, it was a bit smaller. And the major change was the channel audio layout API that was started in 2014, I think, that was around. I wanted that to be inside FFmpeg 5.0. I couldn't get that. We did a lot of work on ARM assembly for the people who are basically running Graviton and people who care about ARM on the server side. JPEG XL, SVT AV1, and of course, tons of new filters and probably 1 or 2 audio and game codecs, right? So the channel layout API is important because it's what is going to help you to do next generation audio, right? Whatever that means. But that's basically anything that is not normal layouts, right? So ambisonic, object-based audio. In the past, you couldn't do that, especially because there was an actual limitation of 64 channels in FFmpeg layout. So now you can have any number that you want. I think you have 2 to the power 64, so enough, right? It's ready to have ambisonics and NGA, and basically it's a list of channels, right? So you can either have the one that we default and describe, or you can do your own, right? And so either you have like mask-based ordering, like we did in the past for old API and then Windows API. You can have fixed order ambisonic, or basically you can have like your explicit list of channels that you want, so you can do any object-based audio. So what is next? Next is FFmpeg 6, which is going to be this winter. So far, a bit of API changes, not many, but the biggest change is multi-threading of FFmpeg CLI. I know a few of you have redeveloped some wrapper around libAV codec and libAV format to be able to multi-thread, which is important if you're going to do Dash or HLS or even like multiple encoding and resolution at the same time. We are doing that. It's a massive work. It's going to take probably 6 months to 1 year to do that, because a lot of places on the demuxers and the decoders and the filters are not thread safe, which is why the disentangling between AV codec and AV format was useful. We're starting to have RISC-V optimization because I guess someone has hardware or good emulator. There is a new FFT that is quite optimized and sometimes better than FFTW. We have a new API for reconstructed frames from encoders and some changing for hardware for high bit rate, high bit depth pixel formats. So more pixel formats, which is something I hate, but you know what? Like I lost that battle. So multi-threading. So as I said, the changes are you're going to see the result at the end, right? But there is a lot of work to clean the code from FFmpeg. And then you will be able to do one-to-many transcoding, or being able to gather metrics, but not slowing down your encoding. And we need to do for every component in the transcoding pipeline, demuxing, decoding, filtering, encoding, muxing, and so on, in its own thread. So this is being done right now. I'm not sure how much will be in 6, but I hope quite a bit. So, as I promised last year, I managed to move the community to get release schedule on time, which is one major ABI and API break per year, meaning, and that's going to be in December or January, so that we can be in the next Ubuntu freeze, basically. And then we will have a minor version, so like 5.1 and 6.1, after 4 months or after 6 months, probably 6 months. And of course, smaller releases for security. But then we will get one LTS version every 2 years. And that is important, especially if you have some patches on FFmpeg, mostly to have hardware encoders or hardware or non-open source codecs, which you shouldn't do, but I know you are doing. So you know that this version is going to stay around for 2 years, right? So for example, 5.0 was in January, 5.1 was in July, but the 5.1 is therefore LTS, right? Because it's the last 5.0, and it will be supported until July 2024, which gives you around basically 2 years of support, right? We will support the security issues. 6.0 is going to be a normal release, and 6.1, so for example, 6.1 will not be maintained too long, right? So if you want LTS, you stay on 5.1 for 2.5 years, and if you don't care, then you just follow the 6.0, 6.1. And of course, the next LTS will be FFmpeg 7.1 in July 2024 until I don't know when. So for a lot of people like you and everyone that is extending FFmpeg, this is important. And it seems logical, but you have to remember that it's extremely difficult to move some open source community, mostly when they're based on volunteer people doing that on their free time to actually commit to that. Next, I'm talking about David. So David 1.0 was released this year, probably April or May, I don't remember. So now we have tons of assembly. v7, ARM v8, x86 32 bits, 64 bits for SSE, AVX2 and AVX512. It's around 200,000 lines of handwritten assembly. Yes, we are faster than intrinsic. Yes, we are faster than compilers. Yes, even with the vectorization on, et cetera, et cetera. Yes, this is huge. I don't think there is many other projects that have as much assembly. To give you an idea, there is more assembly in David than the whole FFmpeg. We had a new threading model because a lot of you complained in the past that they couldn't understand how to tweak in the best way the threading between the frame thread, the slice thread, the filter thread, and so on. So now you don't care. We do it magically, right? So we just give a number of thread and we'll do it magically. Now it's on VLC, of course, FFmpeg, Firefox, Chrome. The extension on Microsoft for AV1 support is based on David. I think even Apple, I'm not sure, is shipping David. So in the performance, yeah, on single thread, we're a lot faster than GAV1, which is the only other decoder that actually can match David. 50% faster on x86, 10 to 20% on ARM. That's single thread, and when we move to multi-thread, David is a lot faster, as you can see, because the scaling of David is well done. And so what's next for David? Probably more assembly optimization. We might get 5 to 10% better, but I think that's going to be basically the best way that we can do. Therefore, some use case like image decoding, where it makes sense, it's easier. If you have extremely high threads, the scaling, the automatic scaling is not perfect, so we can do things like that. And one of my pet peeves, if you remember, we might be able to do some GPU decoding, so a kind of hybrid decoder where we're going to do some of the CPU and some of the GPU, which is not going to improve the FPS, but at least decrease the battery consumption for the same FPS. So remember, FFmpeg, David, X264, most of that is open source community, people working, volunteers on their free time for you. Most of the work that you've seen basically on FFmpeg was done because of the sponsorship from Meta and YouTube. So maybe some others could help us also and sponsor our work. And thank you, and I'm out of time.